Hello everyone. Today we will use this simple snake game to learn how to debug any C++ program in a practical way. By the end of this tutorial, you will be able to debug C++ programs with confidence. Here is what we'll cover: breakpoints and conditional breakpoints, watch window and locals window, call stack, stepping in, out and over, data breakpoints, modifying values during debugging, run to cursor or fast forward execution, set next statement or how to skip or repeat code execution, and pausing execution. Let's jump right in. You can download the source code of the game from the following URL. Breakpoints. A breakpoint is a marker we set on a line of code to pause execution at that point, allowing us to inspect variables and program flow during debugging. To put a breakpoint, for example, on line 12, we need to click on the left of the line number or press the shortcut of your ID in Visual Studio, that is F9. Let's run the game and see what happens. We saw a window pop up briefly, and now the execution paused on this line. We see that some game object was created, and if we open the game, we will see a black window. That's because nothing has run yet. Let's go into the run function. We can do that by pressing F12 or go to definition and put a breakpoint here. This is the game loop. The game loop is the main logic of every game. It runs continuously, processes input, updates the game state, and renders the game. Let's press continue and see if we will pause here. As we can see, the game is still a black window because the loop hasn't executed even once. Let's press continue again. And now we see that the splash screen was rendered. We see that this breakpoint is hit over and over again because the loop runs continuously. To disable a breakpoint, we need to right-click on it and click Disable, use the indicated shortcut, or disable it from the Breakpoints window, which I have it open here on the bottom. If you don't have it open, you can open it from Debug, Windows, Breakpoints. And you can also put it wherever you like. Conditional breakpoint. Breakpoints can also have conditions, meaning they will only pause execution when a specified condition is met. For example, let's put a breakpoint on line 66 and add the following condition. Let's right-click on the breakpoint, press conditions, and write current equals 5000. So when the current tick becomes 5000, the breakpoint will pause the execution. Press enter and close that window, run the game. Now, if we wait some time, we expect the breakpoint to be hit. As we can see, the current tick variable equals 5000. Keep in mind that adding conditions in performance critical code as the game loop can slow down the program and make it very hard to debug. So in such cases, it might be better just to add an if statement here and put a regular breakpoint inside. Locals window and watch window. The locals window and watch window are used to inspect variables in the current scope or context. The locals window automatically shows all variables that are in the current scope. For example, let's first remove the condition we previously set on this breakpoint and run the game. To open the locals window, we need to go to Debug, Windows, and Locals. I already have it open here on the bottom. As we can see, here we have all local variables. We have the this pointer, current, which we see its value, last update, and delta seconds, which has some garbage value because on that line is not yet defined. If we put a breakpoint on the next line and press continue, we will see that its value will change. The watch window allows us to manually add variables or expressions to track. To open it, we need to go to Debug, Windows, and Watch. I already have it open. To add a variable or expression, we can right-click on it and choose Add Watch. We can write it here as well. Or we can choose it by hovering on some variable and right-click and add watch for some more complex variable. We can also write complex expressions here. For example, mQuit equals false, which will be true. We can also add local variables here. Basically, we can add all kinds of variables and expressions. We can even run some functions which don't have side effects. Now let's put a breakpoint in some other function, for example, process state changes. And continue the execution until we pause here. As we see, all the variables we put in the watch window are now grayed out. That's because they're not available in that context. We can add other variables, for example, m is removing, which is a field of the state machine. If we open the locals window, we see that the only local variable is the this pointer. Now let's talk about the call stack. To understand it, let's first review what a stack is. A stack is a last in, first out data structure, or LIFO, and it's just like a pile of books. You can only put new books at the top, and you need to remove the top book to access those below. So the call stack of a program stores the currently active function calls. For example, let's enable the pointer in process state changes and to run the game. To open the call stack window, I already have it open. To open it, you need to go to Debug, Windows, and call stack. If we look at the call stack, we see some entries. Those entries are called frames. If we double click on some entry, we switch the context to that frame. For example, let's double click to the main function. Here, if we open the locals window, we will see all locals variables of the main function. And in the watch window, we will see only variables that are valid in the current context. Now we see in the main function that the run function was called. If we double click on it, we will see that currently the process state changes was called, and that led us to that breakpoint. We can disable it and put another breakpoint. For example, let's open the snake file and put a breakpoint in advanced snake position. Let's continue execution, start again, and now we paused in advanced snake position. If we open the call stack, If we double click on the main function, we see that the run method was called. Here the update method of the active state was called, which called the tick method of the world, which called the tick method of the snake, and the tick method of the snake called the advanced snake position. And here we can see the local variables. In our watch window, we don't have any variable that is available in that context. Stepping in, over, and out. When a breakpoint is hit, we can execute code step by step. Let's remove this breakpoint and put it here before a function is called. Press continue. We can do step in, step into, which will enter into the function. If we press here or use F11, we will go inside the getGrid function as if there was a breakpoint here. Do it one more time, and now we expect to go inside set sales status. Let's run continue and pause on that breakpoint again to show you step over. Step over executes the current line without stepping into the function. So if we press this, the line was executed, but we didn't go inside getGrid and set save status. The last one is step out, which exits the whole function and returns to the caller while executing the whole function, of course. It doesn't skip anything. So if we press, let's see the call stack first, the advanced snake position was called from the snake stick function. So if we press step out, we will go back to the previous function. It's good to know that it is very impractical to click on those icons every time while you debug. That's why it's useful to use the shortcuts. In Visual Studio, step into is F11 and step over is F10. Data breakpoints. Unlike regular breakpoints that pause execution at a line of code, data breakpoints pause execution when a variable's value changes. For example, let's first run the game. And here we see that we can press F5 to pause the game. Let's try it. Okay, let's put a breakpoint in the main loop again. If we observe the value of the state machine is the it drives the main logic of the game. Each part of the game is different state. For example, we have the splash state for the splash screen, the game state for the gameplay, and the game over state. So here we have the game state, and if we expand it, we will see the field is paused. We can right click on it and choose break when value changes, or add it to the watch window. Is paused equals false at the moment, and right click and choose break when value changes. Now let's disable this breakpoint, continue the execution and press F5. We see that the data breakpoint was triggered and somebody changed the value of is paused. Now this is a small game and a small program, and probably it would be easy enough to find where this variable is changed. But in big projects, this feature of the debuggers is very useful. So here we saw that from the main loop and the handle input of the active state. When the F5 key was pressed, the M is paused field is changed to true. Now we can continue debugging just to demonstrate the previous point of stepping in over and out. If we press step out, we will return to the main loop. Let's press F11 or step into. First, we got inside get active state. Let's press step over to get out and press F11 again, step into to get inside the update. Now we can step over as many times as we want and inspect every line of code. You can also set a data breakpoint on a memory address. For example, the address of mnew state. Let's add mnew state to the watch window and use the address of operator to get the address of the mnew state. Let's copy the value, go to debug, new breakpoint, data breakpoint, and put the address here. Now, mnew state will be changed when a new state is pushed to the state machine. For example, when the snake dies and we go into the game over state. So let's continue and see if our breakpoint will be hit. Let's first click F5 to unpause. We see we hit again the breakpoint for pause. Let's disable it for now and continue again or press F5 in Visual Studio. Now let's kill the snake. And we see that the execution paused because the value at that address changed. If we look at the call stack, we see some function called notify game over. If we double click on it, we see that here to the state machine, we push the game over state, which essentially changes the new state variable. Some debuggers allow data breakpoints for read access too, which means pausing when a variable is read. However, this is not supported in Visual Studio. Modifying values during debugging. While debugging, we can modify variables in real time. So now we will practice everything learned until here. Let's run the game and put a breakpoint in the game loop. Now I'll use step into, step over, and step out by using the shortcuts, and I will tell you what I'm doing. Now I'll hit step over as many times as it has to reach the update function of the active state. Now step into, first we will get inside active state. Let's step out, step into again, and now we are in the update function of the game state. Let's step over until we reach the tick function of the world, step into. Now we'll go inside the tick function of the snake, step into. And now step over until we reach advanced snake position and step into again. Now, if we look at this code, we will see that when we hit an apple, some variable code some field of the snake class, move time seconds is changed. And every time an apple is hit, it's changed to a lower value. So the move time seconds is the time in seconds for which the snake moves into one position. So the smaller the value, the bigger the speed of the snake. As we can see, every time we eat an apple, the speed of the snake increases. Now, while inspecting that value, I can click here and put whatever value I like. Also, I can do the same thing from the locals window for some local variable. And I can also change values from the watch window, for example. If we put the move time seconds here, I can also change it from here. So let's change the value to 1. And now we expect the snake to be really, really slow, to move 1 second per position. Let's disable the breakpoint in the main loop to be able to run the game. We see that the snake is really slow. Let's put the breakpoint here and change the move time to 0.05 seconds, which will be very fast. Let's press F5, which is the same as continue. Sorry, let's disable this breakpoint because this function is called on every tick. So let's press F5. And now we see the snake is really fast. Run to cursor, or how to fast forward execution. Instead of stepping through every line as we just did, we can fast forward the execution to a specific line using the run to cursor functionality. So let's do the same we did before. Let's put the breakpoint in the main loop. Let's run the game. If I want to go to reach this line, what we did before was using step over as many times as it has to reach that function. Let's press continue to go back again at the pointer. Instead of doing that, we can right click on this line and press run to cursor. This will execute all the code and will pause at that line. We can also use the run to cursor to pause at another function that we know will be executed. For example, I will temporarily disable this breakpoint to be able to start the game. Now, let's enable this breakpoint. Go into the advanced snake position and click run to cursor. What just happened? We were paused at that breakpoint, and when we hit run to cursor on the advanced snake position, all code was executed until here, which was essentially just like putting a breakpoint here. Set next statement. Skip or repeat code execution. We can skip or repeat certain lines by using the set next statement functionality. For example, let's go into the advanced snake position and put a breakpoint inside the hit apple if statement, which breakpoint will be hit when the snake eats an apple. Now let's run the game. Eat an apple. We see that first the apple will be moved to some free position, and here is the code we looked before, which sets the move time. We can press F10 or step over to execute this line, which decreases the value of move time seconds. And if we want to repeat that code, we can right click on this line, choose set next statement, and step over again, which we see reduces even more the value. We can set next statement again, execute the code again. We can also set next statement to be in the else clause, for example, or even we can set the next state to be the game over state. As I said, set next statement skips every code that has to be executed and sets the next statement to be the one you chose. Keep in mind that doing that may corrupt the current program. So first, let's go back here to demonstrate you that the speed was changed. Let's do it one more time. Press continue. And we see that the snake moves faster now. Let's eat another apple. And set next statement to be the game over. Continue. And we see that the game ended. Pausing. And lastly, you can pause the program at any time to inspect its state. That is not so useful most of the time, but it can save you if your program hangs and you suppose that there is an infinite loop somewhere. Let's run the game. Here is the pause button and see what will happen if we click it. As we can see, we are currently in the game loop, and here we see some functions from the SDL library being called, for which we don't have symbols, and that's why we don't see what is the function name. Pausing is very useful if your program hangs and you suppose there is an infinite loop somewhere and you want to see what's going on. For example, let's put another loop here in the game loop. Enter on the game. As you can see, now there is a black screen and nothing can be done in the game. If we click pause, we will see that the currently executing code is this infinite loop. That's it. Now you have everything you need to debug any C++ program like a pro. In the upcoming videos, we will dive into even more exciting C++ topics, so make sure to subscribe. And if there is something specific you'd like me to cover, drop a comment below.